Hi everyone. So what I'm going to do for this unit, just because I noticed that a lot of you guys were having internet issues over the last couple of units, I'm going to be also recording videos where I go over part of the lesson. Some of it's going to already be written, I'll just go over it, and some of it I'll show you how to do it as I recorded this video. So the first one we're looking at right now is solving linear systems by graphing. So it's important for us to remember what a linear equation is. An equation that relates two variables so that an ordered pair is satisfies the equation and forms a straight line. So to translate that, we got two different versions of linear equations of how we can set it up. We have y equals mx plus b, where m is our slope and b is our y-intercept. This other guy is standard form. We just have the equation equaling to 0. It's still a linear equation. We just have to rearrange it in order to get y equals mx plus b and something that is easily graphable. So anytime you want to graph an equation, this form is our fave. This is less fun, but we could use it. We would just have to find the intercepts. Annoying, but doable. Now, linear system is when we look at two or more linear equations and we consider them at the same time. And usually what we're doing when we are using linear systems is trying to solve for them. And solve means basically finding the point of intersection, or the POI. So it's that point where the two lines cross, or the point that satisfies both equations. There's three ways this could happen. One, never, because the lines are parallel. The other way is once. Lines are straight. They do not go all over the place. Therefore, if they're going to cross, they're only going to cross once because they're going to overtake each other and then never see each other again. And there's one other way, when infinitely, when they're the exact same line. Now you're saying probably like, okay, like that's should be obvious. If you have two equations, you should be easily able to see that they're the same line. Well, you could have them written in two different forms, and then you wouldn't recognize it right away until you are graphing them out. Same thing with parallel. One could be written in y equals mx plus b, and you can easily see what the slope is, but the other one could be written in this standard form. And then you wouldn't easily be able to see what the slope is. So you wouldn't know until you started graphing it. So let's look at this first one here. So we have equations for two lines. X minus y equals -1. 2x minus y equals 2. So this is line A and line B. The question is asking us to solve the system of equations, which means find the POI. So our step one here is to put our lines in intercept form. Again, the reason we say put it in intercept form is so much easier to graph something in intercept form than it is in standard form. Just super easy. We can plot where our y-intercept is and then just use our slope to do rise over run and quickly graph it. So as you can see here, I've done the dots, if you zoom in, to go up. And on the other one, I have the dots also for the other line. I just used different colors so it was easy to see which was line A and line B. So after you solve your equations, you see them in y-intercept form, you graph them. And then when you graph them, you should be able to see where they cross. Now, sometimes you're going to have a huge graph you would have to fill in order to be able to find it. But in this case, it's nice and easy, nice and obvious. Our point of intersection is 3 and 4. Checking our solution. Now, with a point of intersection, if you looked up here, it's a point that satisfies both equations. So what that means is if we shove in the x into the equation, we should get the same left side. So looking here, we're going to look at between the two of them. I put the 3 in this one to see if I would get 4. Put the 3 in this one to see if I got 4. Yep, they both gave us the right information, and we are good to go. Both have left side equals right side. Here's another example. This is a real world application of how you can use these sorts of equations to figure out things that you might need to know every day. If you are planning your wedding I know this is a long time away for you guys, and you probably have your parents helping out or your guardians, but this is a legitimate thing that you guys might actually need to figure out is to see which banquet hall is going to be cheaper. Because when you go to have a banquet hall, you're not just renting the place, you're also going to be renting the place based on how many people are bringing it. So most banquet halls, they charge you by how many people you bring. The more people you bring, the more they're going to charge you to rent out the hall. So Brian and Catherine want to rent out a banquet hall for their wedding. A party hall charges $50 per person. So I've created the equation. So their price is equal to $50 per person. So put the X, this is how many people are coming. Now, Super Cheap Hall charges a fixed rate for $2,000 plus, that's your starting price, $30 per person afterwards. So we can have $30 per person, that comes from here. This is super cheap, plus that initial value of 2,000. I created a table of values just because it's easier when you're using these types of equations where it just isn't as easy to just go rise over run, rise over run. It doesn't really work with huge numbers like this. So graphed it out and I found a point of intersection, which you can also see in the table of values. It's here and here. Now, this is going to be a question that you might have to answer if you ever were renting a banquet hall. Could be for a quinceañera, a sweet 16, a wedding, or anything else like that. So if Brian and Catherine expect to have 80 people, we need to figure out which hall is the better option. So if we go and look up here at 80, you can see that our party hall is cheaper. It is below our super cheap line. So at that time, we're going to say party hall is our best bet because, well, it's cheaper. We don't want to spend as much money. Here the question is, under what conditions would you recommend party hall? So what that really translates to is, what point is it cheaper to use party hall than it is super cheap? If we look up here, again, you can use this graph so you can see it, is right between 100 and 0. Party hall is below super cheap's line. Therefore, it's cheaper. But once we reach that 100 people, super cheap hall is cheaper because it's below party hall's line. So we can just write that. Party hall when you have less than 100 people, and super cheap hall when you have more than 100 people. So that's an example of a real world practice. We could put this type of mathematics to work for us and save us money. Here we have another equation. Right now we can see this one here is in y-intercept form. This one is in standard form. So our first step, let's just quickly go and plot our one that's already in y-intercept form, our purplish pink line. I'm going to draw in purple. So we start off at 4, because that's our y-intercept, and we're going to go over 1, up 3, because that is our slope. And then going the other way, down 3 over 1, down 3 over 1, down 3 over 1, and just keep repeating it, feel like a broken record, until you get it done. That was a terribly drawn line. Let's try that again. Yeah, close enough. All right, and then the next line. Right now, it's in standard form. Standard form is hard to graph. We don't know our y-intercept and we don't know our slope. Easiest way to deal with this is rearrange it into a format that we can recognize. And what I mean by in a format we can recognize, I mean, let's put it in y-intercept form. So I'm going to move it around, get 2y equals 6x minus 10. Y cannot have a friend. It must be lonely. So we're going to divide by 2, get that 2 away from it. 6x divided by 2 gives us 3x. Negative 10 divided by 2 gives us negative 5. Okay, that's a format that we recognize. got our y-intercept, and we got our slope. So let's graph this. Y-intercept's at -5, over 1, up 3, over 1, up 3, over 1, up 3, over 1, up 3. Keep doing this until you feel like a broken record, and you got to plot it. Now go the opposite way, down 3, over 1. That was short. Let's move it down, get our lovely little way to make a straight-ish line. Pray it works. There we go. Uh-oh. What's our POI? You notice. This guy hangs out over here. This guy hangs over here. They're going the same way. Kind of look parallel. That's because they have the same slope. Remember, parallel lines have the same slope, and parallel lines will never meet. So what we can say here is there is no POI because they are parallel lines. Again, we can recognize parallel lines by the fact that they have the same slope. And we didn't notice this because one was in y-intercept form and the other one was in standard form. It wasn't obvious to us that they were the same slope. So let's try another guy. On the same grid graph lines, x plus y2 equals 4 and 2x plus 4y equals 8. And we want to use our x and y intercepts. So how we're going to do this is by making the opposites equal. So if we're looking for x-intercept, y is going to equal 0. If we're looking for a y-intercept, x is going to equal 0. I'm going to highlight these so we can see which one we're dealing with. So in green right now, we're going to use this line, and I'm going to write in green. So what we're going to do to find out our x-intercept is we're going to make y equal to 0. So putting our information here, we have x plus 2, we're going to put 0 where the y should be, so we can get our x-intercept. 2 times 0, anything multiplied by 0 gives us 0, so then we get x equals 4. Now y-intercept, we're going to do the same thing, except we're going to make x equal 0. So then we're going to do 0 plus 2y equals 4, because that's 2y equals 4. And we're going to divide by 2 on each side, and we get y equals 2. So we're going to plot these 2 points so we can see them. I already had them plotted in, and I'm going to use a ruler here and connect them. Now, this isn't necessarily the best way to do it because when you're drawing at the line, you might not get it properly. Oops, like I didn't that time. Let's try this again. But it kind of works. Hopefully we get it good. Close enough. And now we're going to look at the other guy. The other guy's going to be in blue. And we're going to do the same thing. We're going to find out what their x-intercepts are. So, and our y-intercept. So x-intercept, we're going to make our y equal to 0. So we get 2x plus 4, 0 equals 8, which gives us 2x equals 8. We're going to divide by 2 on both sides. Oops, those were not very well drawn 2s. Let's fix that. So x equals 4. So I'm just going to put y equals 0, x equals, wait a minute. We already kind of accidentally found our POI, but we will continue so we can actually draw this line. So let's go with our y-intercept. We're going to make x equal to 0 this time. So x equals 0 plus 4y equals 8. For y equals 8, divided by 4, divided by 4, y needs to be all alone. We get y equals 2. What is going on here? Are you noticing what I'm noticing? Because I don't want to do blue on blue, let's see if we can get this. Something seems a little bit up here. What's going on? Do we have one POI or do we have an infinite number? Well, I would say we're going to have an infinite number of POIs. And the reason why the equations represent the same line. Now I'm going to go up to show you what happened here. X plus 2y equals 4 could be our base equation. And then it was multiplied by 2 every single item to give us 2x plus 4y equals 8. These are the exact same lines, but they're just being expressed slightly differently. One's been multiplied out by 2, but it still represents the same line in the same equation. So this is why when we look straight at equations, we might not immediately notice that they are the exact same line. This is an example where you're going to be going like, why didn't I notice this earlier? Because that would have saved me a lot of time. But this is an example where you're going to find an infinite number of points of intersection because they are the exact same line. So if a linear system has no solutions, keyword here, no solutions, then the two linear equations have the same slope and different y-intercepts. It's the only way they're not going to be the same. This is an inconsistent system, aka they're parallel lines. So if I'm going to draw this out, see if I can get this good. That's like having one like this, and then another line like this. Hopefully, yeah, it's not quite parallel. Hopefully we can get this. That looks parallel. Now, if a solution only has, I'm going to switch colors for this, one solution, then the two linear lines have different slopes. This is just summing up what we've noticed. So this means it is a consistent system, and they are intersecting lines. That means they actually go through each other. So again, we could have an example where we have one going like this. And then we can have our secondary one going through it like so. They go through each other. So that is an example of a consistent system. Now, if a linear system has an infinite number of solutions, like that last one that we did, infinite number of solutions, that means the two linear equations have the same slope and the same y-intercepts. They're dependent systems. They depend on each other, aka they're the same line. So I'm going to show this by having one of these lines being highlighted, and then I'm going to go through it the exact same way with a red line. They're the exact same lines. In other words, if you want to determine the number of solutions that a linear system have, just check how the slope and y-intercept compares. So if you have the slope and y-intercept being the same, that means they're the same line. If you have two lines that have the same slope, they're parallel, which means they're never going to cross. So there is no POI. Now, if you have different slopes, then you're going to have a system that will cross at one point or another. It may be on where you're graphing it, but they will cross at some point. So these are some examples that I want you guys to go over and try graphing. See what happens. We're going to do a couple of these just right now. Let's see. And we're going to use Desmos in a bit. But there's another way you can do this. Use Desmos to just check your answers. But how we can quickly do this, remembering this information over here, you can find out how many intercepts you're going to have. So our first one here, we have y equals 3x plus 4, y equals negative 3x minus 4. Looking here, if you're quick and you just notice 3 and 3, 4 and 8, could be like, oh, they have the same slope. Their thing. But we need to be aware of our negatives. Pay attention to that negative. They have two different slopes. Two different slopes. That means they're going to have one POI. Let's look at system 2. We have y equals 2x plus 3 and 2y plus 4x equals negative 10. Okay, they're not in the same group here. Let's make this guy into y equals mx plus b format. Let's put this in intercept form just to make sure we got the right guy. 2y equals negative 4 minus 10. Okay, y equals negative 2x minus 5. Okay, again, let's look at here. Negative 2, positive 2. Okay, we're good. We can now find out that there is one POI. They have a different slope, different y-intercept. They're not the same line. Therefore, we're good. Okay, we have 0.8x plus 3x plus, 0.8x plus 6 equals y. 4x minus 5y equals 10. Okay, let's see here. Let's check this one out. Alrighty. Let's put this into the same form. We got 5y equals 10. Let's put the negative 4x minus 10. Okay. You divide this out. Get that y by itself. This is the one and only time I'm going to tell you guys to put your slope in a decimal form. Negative 4 divided by negative 5 is going to give you 0.8x. And negative 10 divided by negative 5, that's going to give you positive 2. Do you notice something? What are the same? Well, the slopes are the same. So if the slopes are the same, these lines are parallel. Therefore, also one thing that's important to note, which I didn't quickly skipped over, is our y-intercepts are different, which means they're not the same line, even though they have the same slope. Therefore, there are no POIs because they're parallel. They're parallel because they have the same slope, but different y-intercepts. Okay, you guys can at this point probably guess what's going to happen with this guy here. They're most likely going to be the same, but let's confirm. Let's put these both in y-intercept form. So we got 4y equals negative 3x plus 2. Let's divide these by 4. So we got y equals negative 3 over 4x plus 1 over 2. Okay, we're good there. This bad boy, let's do the same thing. So I'm going to bring this guy over to the positive side. I'm going to do negative 6 minus, nope, plus because I brought it over to the other side, 4. Let's divide it out and get y equals negative 3 over 4, and 1/2. You're going to notice something here. These guys are the same. So there's going to be infinite POIs because they're the same line. Same line, identical. So these are some practices you guys can go over. Again, just click them on the document and you'll be good to go. And here's your assigned work. So you're going to be matching the statements, figure out which ones of these connect, and using Desmos. Now Desmos is, I'm pretty sure you guys have seen it, but let's just double check so you guys know what it looks like. I'm just going to go over here. It's this app. You can download it on your phone. You can go to desmos.com and it'll be up. You just put in whatever equation you have. I'm just going to put in a normal one that we kind of use all the time, y equals x, and you can add different ones. So y equals 2x minus 3. Let's see if these even connect quickly. Ah, there they go. And then you can easily see where they're going to connect on here. Now, sometimes your intersections are going to be really far out and you'll just have to keep zooming out. I recommend using this on either your computer or your phone. If you have a tablet, it's also really easy to use, but this is different ways you guys can use it and get everything done. Okay, so this is your assigned work you need to be working on. It's a couple pages. Try it out. And then next day, we're going to be looking at substitution. This is another way of solving linear equations.